In today's lesson, we'll be learning how to transform quadratic relations. Take a look at this quadratic relation in vertex form. Our a value is -1, which means our parabola is going to be frowning or opening downwards. Take a look over here. You'll notice that there are no brackets, which means our original h value had to be a value of 0 because x minus 0 is just x, which means we don't really need the brackets. So our original h value is 0, which means our parabola is neither horizontally translated to the left or to the right. And lastly, our k value is +6, which means our parabola is going to be vertically translated 6 units upwards since this is a positive value. If you recall, this is the parent function of a quadratic relation. Y equals x squared represents a parabola in its most simplest form before any translations have occurred. Based on the information we discovered earlier, we are going to reflect this parabola across the x-axis, which means it's going to be opening downwards or frowning, and we're going to move it 6 units upwards. Let's begin by reflecting our parabola across the x-axis. If you take a look at the images of Mr. Fantastic, I want you to picture him flipping upside down, and that should help you visualize what this new parabola looks like when it is frowning or opening downwards. Next, I'm going to move my vertex 6 units upwards. I'm going to move a second point 6 units upwards. And I'm going to move a third point 6 units upwards as well. I've gone ahead and moved the last 2 points 6 units upwards as well. As you can see, our newly transformed parabola has been reflected across the x-axis. In other words, it is frowning or opening downwards. There were no horizontal translations. In other words, it wasn't moved left or right, but it was moved 6 units upwards. In our second example, we have a quadratic relation in a vertex form. Its a value is -1, which means it's going to be frowning or opening downwards. Our h value is +9, which means there's going to be a horizontal translation 9 units to the right since this value is positive. And last but not least, you'll notice that there is no value right over here, which means our original k value must have been 0, because if you add 0 to anything, you don't really need to write that in. In other words, our original k value was 0, so there was neither a vertical translation upwards or downwards. Based on the information we've just gathered, our newly transformed parabola will be reflected across the x-axis. It's going to be frowning or opening downwards, and it's going to be moved 9 units to the right. Let's begin by reflecting our parabola across the x-axis. You'll notice that it is now frowning or opening downwards. Use the images of Mr. Fantastic to help you visualize what the newly transformed parabola looks like. We're really just flipping him upside down. Next, let's move our vertex 9 units to the right. We're going to move a second point 9 units to the right. And we're going to move a third point 9 units to the right. I've gone ahead and moved our last 2 points 9 units to the right as well. As you can see, our newly transformed parabola has been reflected across the x-axis. In other words, it is now frowning or opening downwards, and it has been moved 9 units to the right. There were no vertical translations upwards or downwards.